So these are kind of like yesterday to some degree. Evaluate the expression. We might have to go over a rule, I don't know. But what's the understood base of a log if it's not mentioned? 10. Now, there is a rule we're supposed to talk about here. I don't know if you remember or not. But a logarithm was an argument that happens to have an exponent, which is oddly enough called r. Do you remember where the r goes?
In the E. No, the front.
Goes to the front.
Yeah, that's it. So
It's r log a. So if I was looking at number 1, I'd shift that 2 to the front. I have 2 log bases of 10, argument 10. And it'd be really cool if you knew what log base 10 of 10 is asking.
No. Yeah.
The base is 10.
1.
So the answer is 1. The question is what power of 10, what power of the base is equal to the argument. So it is 1. Now there's already a 2 out front, so it's 2 by 1. This shall be 2.
Okay.
Look at number 3. We have negative 2 natural logs of e. And like knowing log base 10 of 10 is 1, knowing natural log of e is also what?
1 is E. Wait, it's 1.
It's 1.
Yeah.
Are things that we just memorize. So you definitely need to memorize that natural log of e is 1. These we memorized. If you can memorize it, stuff's super easy. Alright, so there's first 3 covered, 1 of 8 slides. You got some simplification here from 2, because this is about x1 as this section is. And we'll do number 9. 9's a good one. Lots of little things we can do first, like on 9 I've got an exponent of a half up top and a third down low. What can we do with that thing?
No, you can't raise it. Could you raise it like a...
The deal was, if you have something with an exponent raised to another exponent, you multiply exponents. That's the property. I've always kind of called it a distributive property, because that's exactly what you're going to do.
Yeah, okay.
So half of 2 is 1. So u to the first. Half of negative 4 is negative 2. Down low, and the common mistake here is that kids don't give it to the 27. That's a very common mistake. We'll worry about what it is later. It is 3. I don't disagree with you. Third of 6 is 2. At least I believe it is. A third of negative 6 is negative 2.
It's a V, right?
It is V.
Okay.
Alright. Destiny, you see anything we can just cancel right on out? The V's. They're both of the same power. They're going to annihilate each other. And Maddie's already told us that that's a 3, because that's what root?
With a third.
Cubic, that's right.
Yeah, that's it.
And we've got a u up top and a u down low.
Did not mean to write that too. It's just, it'd be just.
I'm waiting on you.
3U.
It'd be a u, gotta have a 1 up top. You gotta have a 1 up top. And that's how hard those are. But it's a good prerequisite because you're working with exponents today. You're learning the properties of logarithms.
That's cool.
Alright, assuming x and y are positive, use properties of logarithms to write expression as a sum or difference of logarithms or multiples of logarithms. So the 2 big properties on this page, there's actually 3 of them. One of them is that a log of a times b can be broken apart through addition.
Log A plus
Log a plus log b. It doesn't matter if it's a log or an ln, the rule's the same. If you have a logarithm where there's division happening, the thing in the numerator is positive. The one in the numerator is always positive, with a little plus there. The one in the denominator is negative. You break apart division with subtraction. And the only other property you really need on this page is the one we just talked about. a log with an argument with an exponent. The exponent goes out front. It's called a factor. Those are the three main properties. The dual enrollment class murdered those things. I mean, they absolutely murdered them. But anywho, they want us to rewrite this as sum or difference of logarithms or multiples of logarithms, and try to break these things down just as much as you can. Like on number one, the easy move would be to say it's the natural log of 8 plus the natural log of x. But there's more to be done with that, because you're thinking about logarithms. Logarithms are exponentials. So you need to break those down as far as you can. 8 happens to be a power of something. What is 8 a power of? 2. So what you're really looking for is a kid that can't realize that this is the natural log of 2 cubed plus the natural log of x. It's about manipulation. And finally, where can 3 go? Up front. So whenever you're doing these things, you try to break them down as far as you can break them down. And that is as far as that one can be broken down. I guess we'll look at 4. Not a whole lot to do with 4 really. But if you look at your rule about division, you break it apart with subtraction, right? So you'll have a single log of 2, take away a log of y. Is there anything else you can really do with that? Not really. Not that would make it look any prettier. Thanks for the 10 is a very good problem to do. It really is. I see 1,000.
That's 10 to the what, third?
That's 10 to the third. That's right. I also see multiplication, or break apart multiplication.
So addition.
Through addition. You break that apart through addition. So view this as log of 10 cubed plus log of x to the 4th. And it may take you 2 steps to simplify log of 10 cubed, I don't know. But the 3 goes out front,
And the 4 goes.
and the 4 goes out front. But you should not stop there, because what on God's green earth is a log of 10?
1.
It's 1.
Yeah.
If the base and the argument match, it's 1. So you get 3 plus 4 logs of x. So just try to work on those that way as you work through these. And obviously, if you don't get something, you'll get it tomorrow. We'll talk about it. Or not tomorrow, Monday. I don't have to go on the field. I don't have to go on a field trip Monday after all, so I'll be here Monday.
Oh, really? Why not?
Well, Coach Cruz' football team didn't keep winning, so Coach Cruz gets to go now. Gets to stay. Alright, so this is exactly what we did, but the other way around. That's all it is. It's really not that hard.
I wonder how to do
What I've noticed over the years is the one that kids struggle with is subtraction. Not necessarily addition, they struggle with subtraction. Addition becomes multiplication, subtraction becomes division.
No, wait, no, I have
If I was looking at 15, it'd be pretty simple. You'd have a single ln, and all it would be y over 3. The positive stays up top, the negative moves to the left. And that's really all there is to it. So let's do one that's a little harder. Let's do 21. It's really not. There's only 2 of you, so one of you tell me what to do with 4 and 3.
yeah. Exponent.
Exponents. Showing all the work, we have a log of both x and y being raised to the 4th. Take away a log of both y and z being raised to the 4th. It's alright, third. You can't tell I ain't 100% today.
It's IBM.
Now, you get to give that to both pieces.
Oh, we can't choose. I get
They both get the same.
Yeah, okay.
How do you break apart subtraction?
Division.
Division. So you're going to have a single log, and up top is going to be an x to the 4th, y to the 4th.
Over y to the third.
Z to the 3rd. And then you're going to do the rest of the simplification of the day.
What?
I think y to the 4th and y cubed will reduce some y. Seems legit to me. If it doesn't, I've been doing math wrong for a very long time and nobody's ever bothered to correct me. So there you go. Do we need to do any more on that page? Like, does anything on that page look scary? Because if it does, we'll do it. If it doesn't look scary, we won't. 22 looks creepy?
Yeah. Just the whole fact that there's already thingies in them.
Just follow your rule. Factors become exponents. So if I put the 3 here and that 2 there, this natural log is going to have an x to what power?
Of 6.
Nope,
It's not.
it's 9.
How you add them?
Multiply.
Um,
The rule is x to the a to the b is x to the a to b
so how do you add them?
when you multiply like terms together. What you're doing here is you're taking x cubed and you're writing it how many times?
3 times.
3 times. Addition is happening. It's just happening more often than you thought it was.
Yeah.
So you're going to have an x to the 9th and a y to what power? Third. Here you're going to have as a natural log of a y to what power?
2.
The second.
And then it'd be z to the 4th.
Z to the 4th. And you could have done this in a different order and still got the right answer. I just chose to do it that way. Destiny, how do we join addition?
Okay.
What's addition?
Multiplication, we multiply inside.
Yes, ma'am.
Single natural log,
Comes out the
and it contains the product
be right there.
of x to the 9th. We do have a pair of like terms. We have a y cubed and a y squared.
And now we add them.
And then z to the 4th. And there she is in all of your easy peasy lemon squeezy.
Okay, it did look fair.
This book doesn't do too many terribly hard logarithms. Let's see, 29 to 32 is about writing the expression using only natural logs. We have a change of base formula. You may or may not remember it, I don't know. But a logarithm, base b argument a, can become a logarithm of a chosen base for the argument over a logarithm of the chosen base for the base.
Oh, what fifth period did?
Yeah,
That's
fifth
a
grade
good
did
idea.
log base. Destiny, you were in that class. What did Parker Scott choose his base to be? You don't want to say it, do you? You don't have to. But you get to pick whatever your base you want. Now, what they want this to do is just become a natural logarithm. So when we talk about a natural logarithm, log base b of a is simply the natural log of a over the natural log of the base. Let's give it.
So natural log is ln, and then the common is the
Log.
logarithm. Okay.
So like if I did 30, the argument is x and the base is 7. What's high stays high, what's low stays low. You have the ln of x, and it's it over the natural log of what? What would that be over? 7. Okay, why don't we do 32 together?
I want to say it's ln c minus b, and then over ln 5.
That's exactly what it is. And in 33 to 36, it works exactly like this one does, except you're just using a base of 10. Log base, some base is simply log A over log B.
Okay. So
10
wait,
becomes understood.
so when it comes to natural logarithms, what is the very top one supposed to be for them? Is that just another way to write it?
The very top one is, say you wanted to convert base 10 to something else. It makes sense or actually it's for things like this.
Log 2 x equals log 8 to the,
It's for things like that,
okay,
because those can't be solved unless the base is.
that makes sense.
what it's for. It's for a universal way of solving things. I don't know if the author of your textbook talks about those or not. I haven't looked that far ahead. So anyways, let's do 35 together. The goal is to make it a common log, which is a log base 10. So, what goes in the numerator?
I wanna say x plus y.
Yep. What's high stays high. X plus y is higher. It really is higher. Because we call the 1/2 a subscript. Because it's downwind. So what's high stays high. And what's low stays low. If you really want to be super fancy or special, you rewrite the bottom like this. That used to be a tested skill in Alpha 2. To see if kids could manipulate perfectly correct answers and make them look like that.
Briefly went over that.
Yeah, I talked about it, but it used to actually be a legit question they would ask every year. And I haven't paid much attention when all the testing to see if they still do that or not. They tell us not to look at the test. So I don't look at the test. So I don't really know what they're asking me anymore. I just hope I teach it. Alright, what do we have here? We have some matching a function with their graphs. It shouldn't be too terribly hard, but of course it's got weird stuff on it. You need to be thinking about your mom function. You're always going to contain 0, 1. That's a given. What's the other point?
It's b1.
B1, whatever the base is. You never cross the x-axis. Sorry, the y-axis. No, I don't know how good a job they're doing on some of these things. But I think the easiest one to do is this one. This one looks like the easiest one to figure out. That's where I would start. Because think about your first point here. Your first point is going to, your second point is going to be where?
At 6.
And we have B1. So we have a point at 6, 1. And then we shift it which direction?
3 units right.
Right 3. So we're going to have a point somewhere on the graph at 9, 1. And we're also going to contain 0, 1. And it's going to become 0, 4.
So it seems to be C.
I said that backwards. It's not 0, 1. Acting like an idiot. It's 1, 0, isn't it?
Yeah. I see it now.
It's going to have 4, 0.
Yeah, which then would turn out to look like C. Yeah.
And that doesn't go up to 9 units, but it goes out to 8. Doesn't it look like it's going to hit 9, 1? This goes out 8 units. You'd be about right here at 9. It looks like it's going to run smack dab into 9, 1 to me. So yeah, that was the easy one. And the next easiest one is 45. I'm going to say that one for y'all. The hardest one up here is probably 46. Because 46 has got a reflection. Got log of 7/10 of negative x minus 3. We're just going to think about the points that we know have to be on it. We know that we have to have 1, 0. You shift it right 3, that's going to be, what, 4, 0? Maybe we should make sure I'm doing order terms first. The order's block.
Yeah, so
You reflect it horizontally, negative 1, 0.
Yeah. There's no A or
And then you write 3, 2 zeros apart.
no 2 zeros is D.
That D is going to be a vertical reflection, isn't it? Well, it may or may not be.
Where is it? A and D. No, that one is 3, 0. Oh, yes, would be A. I'll look at it wrong.
what else are we missing here? I see 2, 0.
I see 2, 0 on A. That's the only one I see 2, 0 on position. That's not an issue.
What would your other point be? Your other point would be 4.7, which seems a little high. I'm going with A, based on 2, 0. But I'm going to leave 43 and 46 to you. Or sorry, I'm going to leave 43 and 45 to you.
No, I get it again.
45 is pretty easy. You just shift the graph right on the S. 2. Like that one's pretty easy. Alright, we got earthquake intensity, and we're going to do just one of these. Earthquake is on the Richter scale, it's a logarithmic scale. It is based on the associated seismic wave is measured by R for Richter is log of A over T plus B, where A is the amplitude in micrometers and T is the period in seconds. B accounts for the weakening of the seismic wave due to the distance from the epicenter. Compute the earthquake magnitude R for each set of values. And it is legit, plug stuff in the formula. The formula's got 3 unknowns, A, T, and B. And if you look at example A, do they give you the 3 unknowns? Apparently they do.
Bro, I'm sorry. It's not my fault.
But these are not hard. This is, how do we actually use logarithms in the real world? We use them on Richter scale, which is a big deal if you live in California. It could be a big deal here. What earthquake fault do we have nearby?
That one by that lake.
New Madrid. It's not even actually by the lake. It's on the other side of the Mississippi River.
Well,
It's in southeast Missouri.
not the lake.
Now, it did form an earthquake. That's what you're thinking.
Yeah.
And earthquakes are on the logarithmic scale. There's a huge difference between an earthquake with magnitude 4 and an earthquake with magnitude 5. 5 is 1,000 times more powerful.
Yeah. Lasted 2 seconds, it's fine.
This is a 6.3 right down the Richter scale. Which would be a big earthquake. You guys ever get woke up at night and you feel like your bed's shaking?
Back in the day, it's been cold in here.
Usually when we have an earthquake, it wakes me up because things start shaking. I feel it. It's not me that's shaking, it's everything else. It happens several times a year. Be glad you're a deep sleeper already. Alright, what's on the last page?
Light density.
Oh, it's another light intensity, just like the one we did in homework. So I'm gonna leave that one for you. There you go.
Literally the same. Okay, sorry.
Literally the same way, do it the same exact way. It is not underlined, so the author of your textbook would like you to use technology.